In this video, I'm going to review and explain some rules for simplifying expressions with exponents in them. Okay, so I'm going to review 3 exponent rules today. The first one is the product of powers rule. So that comes about if we have a certain number to an exponent, like a to the m, and we're multiplying it by the same base with a different exponent, or maybe even the same exponent. So it's how do we simplify that? So let's look at an example here. Suppose we had something like 6 to the exponent 3 times 6 to the exponent 4. How would we simplify that? Well, we can look at what happens if we do that. So 6 to the exponent 3, what that means is 6 times 6 times 6. And 6 to the exponent 4 means 6 times 6 times 6 times 6, 4 times. And now, you may well see where this is going, but let's all, these brackets here don't matter, we're just multiplying a whole lot of stuff together. So, we've got 6 times 6 times 6 times 6 times 6 times 6 times 6. Okay? And now that's kind of a silly way to write this. So we're going to rewrite this with one exponent. So this is 6 to the exponent, well, how many 6's are we multiplying? 1, 2, 3, 4, 5, 6, 7. 6 to the exponent 7. Okay, so how could we have gotten this 7 just by looking at sort of the expression that we started at? Well, 6 to the exponent 3 times 6 to the exponent 4. So the base stays the same, and it looks like we're adding the exponents. And this totally makes sense, because 6 to the exponent 3, and this really could be any number, and we'd write out that many 6's. And then we'd write out however many 6's we had in the second expression, and then altogether we're just adding up those two numbers. So what this rule is, a to the exponent m times a to the exponent n is a to the exponent m plus n. So this rule is called a product of powers because we have 2 powers and we're multiplying them. So it's the product of powers. And the rule is if we have 2 powers with the same base, then we can simplify it by using the same base and adding the 2 exponents together. Okay, the next one's really quite similar. It's a quotient of powers. So what that means, there's 2 ways we could write this. We could say a to the m divided by a to the n, or more commonly, we'll write this as a to the exponent m divided by a to the n like that. Okay, so how do we simplify that? So again, we'll look at an example. Suppose we had, let's say 10 to the exponent 5 over 10 squared. So how would we simplify that? So to see, let's just kind of write out what this means. 10 to the exponent 5 is 10 times itself 5 times. 10 times 10 times 10 times 10 times 10. Divided by 10 squared is just 10 times 10. Okay, but if we look at this fraction, we could simplify the fraction by dividing the top and bottom, the numerator and the denominator, by the same numbers. For example, we could divide by 10, and we'd lose those 2 10s, and then we could divide by 10 again. And then we just have 1 left on the denominator. So what this leaves us with is 10 cubed, or 10 to the exponent 3. And so what happened with these exponents is, if we write this out a certain number of times on the top and a certain number of times on the bottom, then our final exponent will be the top exponent, so the 5, take away the bottom exponent, because that's how many we sort of simplified out. So in this case, a to the m divided by a to the n is equal to the a to the m subtract n. This is the quotient of powers rule, because quotient means that we're dividing. So we're dividing 2 powers. And when we divide 2 powers that have to have the same base, then we can just simplify it by subtracting the exponents. Okay, and there's one more here. which is the power of a power. So for example, let's see, in general, this would be something like a to the exponent m, and all of that raised to the exponent n. Okay, let's look at an example. Suppose we had something like 8 to the exponent 4 to the exponent 3. What would that equal? Well, if we look at that, what this means is a to the exponent 4 3 times, multiplied by itself 3 times. And at this point, to simplify, we could do two things. We can write this out. I'll show you both of them. The first thing is to write this out like the long way, like we did with the 6's. And the second thing is we can use the first rule to simplify. So we'll do it the first way first. So it's 8 times 8 times 8 times 8. And we're going to multiply that by itself 3 times. Alright, and how many 8's do we have? Well, 4 and another 4 and another 4, so we've got 8 to the exponent 12. Or at this stage, we could have gone from here to say, well, using the first rule, that's 8 to the exponent 4 plus 4 plus 4. And we'd still get 8 to the exponent 12. Okay, so what's happening to these exponents here? How could we simplify in general? Well, what we're doing is we've got this many 8's this many times. So how many 8's altogether we have is just these two numbers multiplied together. So a to the m to the exponent n is equal to a to the m n, the product of the exponents. So you should memorize these 3 rules. And you should also make sure that you can always, if you think about it, just explain where they come from and why they work, because they all totally make sense. So you both want to have them automatically, and you want to have them kind of on a deeper level where you can explain them. Okay, good luck with it.